Hey everyone, it's Nick. Welcome back to another duality repair video. I have another scope to look at tonight. It's a Tektronix 2213A 60 megahertz analog scope. And I got this off eBay, again for parts, so there's something wrong with it. You can see it's got, it's in pretty good condition physically. All the knobs and buttons are there. None of them are cracked or missing or show serious signs of wear at all. There's a few stickers on here and some residue, general scratches and wear and tear on the case, but nothing too major. The screen looks to be in good shape. See, there's a sticker on there that says Pegasus Lab that caught my eye. I was kind of curious, so I looked them up. It looks like there's a company called Pegasus Laboratories in Florida. Does some sort of chemical testing and R&D work, so I thought that was kind of interesting. But anyway, there is something wrong with this. I'm not quite sure what it is, so let's turn it on and have some fun. Alright, the scope's plugged in, but before we power it up, I noticed a few things. I guess just one thing. This trace rotation here, it's just an empty hole. And I looked further in there with a flashlight. I don't see any adjustment pot or anything in there. So I don't know if that's missing or for some reason that's just an option that was not included on this. That seems like it should be a standard function, so I'm going to have to open that up and see if that's missing at some point. That'd be kind of a bummer, especially if the trace needs, the rotation needs adjustment. So one thing to note before we power it up. So it's plugged in, let's power it on and see what we have. So I'm on the both channel 1 and channel 2 right now. And well, the intensity sure works, and I certainly only see one channel right now, so let's go to channel 1. That looks like I'm seeing channel 1. So I'm toggling between channel 1, both, and channel 2, and that beam isn't moving at all. So let's change positions. That's not right either. Let's change. Oh man, there we go. Okay. The time scale knob was really stiff. I thought it was just completely seized, but probably just hasn't been cycled in a while. It seems to be working okay. Intensity works really well. So we do have a beam, but the vertical position doesn't work. Oh, whoops. The vertical position for channel 2 works when I'm using the vertical position for that channel. So let's check channel 1. Alright, it was working. Just needed to do the beam fine. Let's do both. It doesn't look very good. Let's see. Looks a little better. Having a tough time triggering. One's got both beams up. Let's see, they're both in AC. Let's try the chop. There we go. Okay, now we're looking pretty good. Channel 1 is adjustable vertically. Channel 2 is adjustable vertically. So everything right now is looking okay. Question is, are we going to get a signal? So let's start with channel 1. And maybe, I mean, I thought it was broken at first, but maybe it's just, I've never seen a probe adjust. I guess it's just a pinhole like that instead of the prong that sticks out. Certainly see a change there. Let's change the volts per division. Yikes. It's a little ugly. That does not look like a square wave. Should be 500 millivolts peak to peak at 100 or 1k hertz, 1000 hertz. 500 millivolts, so we should easily see something right here at 0.5. or smaller. Interesting, what happened there? Not looking too good. Let's check channel 2 out. See if we get anything different on there. So again, I'll go to 0.5 since it's half a volt peak to peak. I'll go even smaller, 0.2. Channel 2 here. That's what I want to see. Yep, channel 2 looks good. So, looks like our problem is with channel 1. Not reading the signal correctly, or really at all. So at 0.2 I should get the same signal as I do here. I got nothing. Nothing at all. Well, of course not. On channel 2. Yeah, it looks bad. That looks bad. So we have a single channel failure. And other than that, you know, everything looks to be good. Again, I'll have to figure out that trace rotation, but as far as major issues, yeah, channel 1's no good. So this does have the service manual available, so I'll pull that up and take a look through it, look through the schematics, and see what kind of relevant schematics we might want to look at, and print those out, and we'll take a look at areas we want to focus on. Alright, so I'm glad I played around a little bit more with the channel 1 volts per division dial there before I opened anything, because take a look at this. So at 1 volt per division we have a nice square wave. And you know, you go a little bit higher and it gets a little dicey, but very nice at 1 volt per division. You go to 0.5 and it looks pretty rough, right? And here, let's see if this makes sense. So 1 volt per division, it should be half a volt peak to peak. So if one division is 1 volt, then we should have about half a division. So yeah, that's pretty close. So what happens when we go change the scale to half a volt? It gets pretty ugly. Same with 0.2, but I notice as well, it's a 0.1, and you go to right there. So you can still see it. You can see the bottom of the square wave here. You just can't see the top because the scale is so big. And I wonder if you can see it. Well, we can do this too. We can move it up and down. Yeah, so you can see that there. And if we go down to 20 millivolts per division, you can see it there. It's getting a little rough. And 10. I'm not seeing much there. Yeah, you can see it there too. But so it kind of just looks like we might have a dirty dial, dirty rotary encoder there. So go back to 1. Yeah, of course it's not reading nicely at 1. Oh, that's because I was messing with the fine adjustment. Let's see if that'll help here. No, not really. So, I'm not going to worry about the schematics at this point. I'm going to open this up and see how easy it is to clean this this knob here in the rotary encoder. That might be our only problem. And while I'm in there, I'll take a look at this trace rotation and see if it's broken off, or it's not supposed to be in there, or what the heck is going on there. So, yeah, we'll figure it out here. Before I move on to opening this, I think it's worth noting that I figured out there is a pot back here for the trace rotation, and it's obviously working. They just, for whatever reason, decided to make it recessed by, that much. About 3/4 of an inch to about an inch. So it is back there, it is working, so I'm not going to worry about that. Just going to worry about these, cleaning these dials up. So let's get it open. The unit's out of the case. Let's take a quick look around. So we have our power supply section hidden in here. It's definitely better protected than the 2205 I just worked on. They have this nice shielding case I'm sure both for protection as well as for noise mitigation. Then of course you have the CRT up here and the high voltage cable leading from the power supply section. Over here we have the front board, so your front panel board that'll distribute your signals like position, vertical position, horizontal position, triggering, things like that. And then down below here we have our attenuation and sweep board. So this is going to relay our signals for our channel 1, channel 2 vertical deflection, as well as our time scale through these. So these are actually for the fine tune adjustments. You can see I can rotate this one. That's the fine tune for channel 1, channel 2 vertical deflection, and then here's the fine tune for the time scale. And then the main vertical deflection adjustment is going to be under here. And you can see the main vertical time scale is right here, but I know that these are slightly different. So we'll have to pull this cover off to take a look. We also have the main board on the bottom. It's one big giant board, and of course Tektronix makes it nice and serviceable. Pull it out and it's all exposed right there. Very nice. Very nice. So I don't think I'll have to be doing any work on the main board here. At least not yet. Get started on cleaning the channel 1 vertical deflection. So I'll take this cover off and we'll see what it looks like underneath. Alright, so in order to expedite the troubleshooting process, let's go through this channel 1 volts per division knob here. Let's go across the entire dial and identify and characterize exactly what the problem is, so that we don't waste time looking at parts of the circuit that aren't relevant to the problem. So I am fully counterclockwise, and let's hook it up to the signal. So with it's such a small signal, it's not going to look very well with the trigger, but it is showing just fine at the 5 volts per division here at the ×1 probe. So let's turn the dial clockwise and see what we get each time. So at 5 we're good. At 2 we're also good. Again, the triggering isn't great. There we go. Still not triggering wonderfully, but you can definitely see the square wave. So at 5 we're good. At 2 we're good. At 1 volt we're still good. Okay. When we get to the 0.5 volts, this should be a really nice looking square wave. Okay, we don't have that there. 0.2 volts, same thing. We should be able to see it. It would probably go off the screen in one or both directions, but we would be able to see it easily, and obviously it's not there. So 0.5 is bad. 0.2 is bad. Let's check 0.1. 0.1 also bad. Right? So all three of these, 0.5, 0.2, 0.1 are bad. Let's go to 50 mil. 50 mil is good. So it's huge, but it's there. It's seeing it very nicely. Let's go to 20. 20 mil. Also there. And then 10. Also there. I can't even scroll to it, but you can see the vertical lines there. 5, same. Intensity is dropping off there. There we go. 5 mil, same. 2 mil, you can also still see it. Low intensity. But they're all present there. Turn that intensity back down. Our issue is going to be with 0.1, 0.2, and 0.5 volts per division only. And that will come in handy, and it's extremely relevant for the troubleshooting process. So keep that in mind. 0.1, 0.2, 0.5. Alright, I have the cover removed from the attenuator sweep board, and so you can see these two rotors here are the controls for the channel 1, channel 2 volts per division adjustment. So let's zoom in here on channel 1's rotor so we can see what's going on. So what's happening here is that you can see along this rotor there are these little nodes jutting out. And what these do is as you rotate, they either press down or they do not press down on these little forks. And so when the node is not pressing down on that fork, there's tension on the fork that allows it to be raised and to be elevated off of the PCB. As you rotate and the node pushes it down, it makes contact with the PCB. So this is what's allowing for different circuits to be activated as you rotate it. Now looking at this, two things. A, I don't see any sort of corrosion or carbonization, any buildup on any of these contacts. I don't think this is a contact related issue. And then the other thing I noticed is I was worried about maybe we lost some of the spring tension in some of these little forks here. But I checked continuity on all 16 as they were down, and they were all continuous. So I don't think that is the issue. I think what the issue is part of the circuit itself that's involved with the 3 volts per division set points. I think something in those parts of the circuit is faulty. So one thing I had to do was the reason I went over earlier which set points were faulty is so that I can help categorize which of these forks may be bad and then which part of the circuits they correspond to. So as you'll see, this is fully clockwise. This is 5, let's see here, fully counterclockwise. This is 5 volts per division. As I rotate through to 2 volts per division and then 1 volt per division, only one of these forks changes in between each. All the rest are the same. So within each area of adjustment, only one fork changes between the two. So now when I change from 1 volt per division to half a volt, which is our first problem area, you get several of these other forks change. Okay, and so now when I change within this range from 0.5 to 0.2, again we only get one fork change. And from 0.2 to 0.1, again, only one change. So then when I go back down to another scale, another range, which is 50 millivolts, I get all these forks changing again. So these are grouped in ranges, and there are 3 ranges of 3 set points. So I did a bit of work. There are 16 forks along this control here, and the only 2 that are common between our faulty range of 0.5, 0.2, 0.1 volts per division and uncommon to all of the rest of them is fork 6 and fork 9. Okay, so I looked really closely at these. I didn't see any buildup on either of them, and I verified they are making contact when they're supposed to with the PCB below it. So what I think we need to do is pull the schematic for this sweep attenuator board and look at the components that are in the circuit making contact with fork 6 and fork 9, and then we have something to go after. You know, maybe there's a resistor in line or a capacitor in line, something that's not behaving correctly, which is why we're getting basically no signal in this range. So I'll pull up the schematic, we'll take a look. I have the attenuator board schematic here, and specifically I have it zoomed in on the channel 1 portion of that schematic, and you'll see I have some things highlighted here. I'll explain that in a second, but what's important to identify is that this whole section right here is the rotary switch. And so if we look on the board here, that's this. Okay, and yes, I did remove the board. I'll talk about that in a second. So let's zoom in on that a little bit. So if we start all the way on the left, we can see that we have our millivolts per division labeling, so 2, 5, 10, all the way up to 5 volts. And then I have 100, 200, 500 millivolts per division highlighted because those are the 3 set points that we were having issues with. So now the way this works is you can see each of these columns is labeled 1, 2, 3, etc., all the way up to 15 at the end. And so in the previous segment I described, I said there were 16 forks or contacts, but I either miscounted or they're labeling or they're counting 2 contacts together as one, and so it's one of those 2 things. And so you can see that these dots here in each column, the dot represents contact and no dots represent no contact. So when the nubs on the rotary dial there are pushing down on the contacts, that's represented by these 3 dots. or these dots, I should say, 3 dots in this case. All right, and so I spoke last time about commonality between these 3 set points and which contacts have commonality. And so if we zoom out a little bit, we can verify that the only 2 contacts that are common to these 3 set points are these 2 right here, the ones I have highlighted. You can see this one, they're not even making contact. This one, they're making contact, but so are the rest of these set points. This one, same thing. They're making contact with the rest of these set points, and etc. The only ones that are common are these 2. So let's zoom in back on these. So you can see contact 5 and contact 8 are the only 2 contacts that utilize the 100, 200, 500 millivolt per division. In the previous segment, I think I called them contactor fork 6 and 9, and so since I miscounted or whatever, they're labeling them differently, I was just off by 1. So where do these lead? These lead up to this attenuator. This 10K attenuator, attenuator 2 here. And so basically attenuator is just 2 capacitors. You can see there's 2 knobs with C1 and C2, C11, excuse me, and C12. And so these are just 2 capacitors inside this attenuator here, and this is a custom package manufactured by Tektronix. And so first thing I did before I removed the board was I adjusted C11 basically all the way in one range and all the way to the other. Didn't change anything. I adjusted C12 one range all the way to one range, all the way to the other, and it didn't make any difference. I adjusted them both at the same time. Didn't show any difference to the signal. So I don't believe that adjusting this is going to fix the issue. And so unfortunately, I think this attenuator is what's causing the issue. Basically, these 2 capacitors in line in this one package. The other thing I did was I tested for shorts or opens between the capacitors and to ground. I didn't see anything different between this attenuator here and the one down on channel 2. So this is channel 2's here. That's the way they have it spread out. So attenuator 52 is for channel 2. I compared continuity between all the pins on this attenuator on channel 2 and channel 1. There was no difference. So what I'm thinking is one or both of these capacitors either have there's some sort of issue with this attenuator. It has to be, because there's nothing in line between contact 5 and contact 8 and the attenuator. There's no resistors, capacitors, any other passives in between here. And this is the only difference between our 100, 200, 500 millivolt per division set point and the rest. This is the only difference. There's no difference at all. The rest utilize similar parts of the circuit. There's commonality between other parts of the circuit between these 3 set points and the rest. So it has to be this attenuator that's causing our issue. So let's take a look at the board. I removed it. And so we have channel 1 here, channel 2. You can see these resistors off here on the right. Those were they're soldered on the back, and then they were soldered to the input connections as well. I just desoldered them and removed the board. So if we're looking at the board here, we have the 2 attenuators right here. And so if we look a little closer, you can see 10x on the top one and 100x on the bottom one. So this is our attenuator that we're going to have a problem with. And they have the Tektronix part number right on there, 307-1013-00. And I looked it up. They have references to them all over the internet, but nobody shows them in stock except for one person in Greece on eBay. And it was $7. So I bought it. That's the only one I could find. $7 plus $8 shipping from Greece. Yes, Greece. I think the $15 is well worth putting into the scope, since this seems to be one or solely the only issue on this scope. I think it's well worth it. With the price I paid for it, putting $15 into it, I'll be able to get the scope up and running. And so, since it's from Greece, it's going to be 2 to 3 weeks before I get this thing in, which is why I'm making this part 1. I'll make part 2 when that comes in. When it comes in, I'll remove this. I'll install that. We'll verify that our issue is gone on the 100, 200, 500 millivolt per division set points, and then we'll also verify the functionality of the rest of the scope. If there's anything else wrong with the scope, we'll attempt to address it at that point. So I will be back with part 2 when I get this attenuator in, and we'll start by installing it in part 2. Thanks for watching. We'll see you next time.